All right, very good. I invite you to go back and open up our exercise 3A basic draw and modify file. We have taken care of the top half in our first set of instructions on using some basic object snaps, using some basic drawing tools, and using some basic modify tools. So we're going to build on what we've already done and we're going to continue. So let's move on to the second level of instruction, and that is object snaps number 2. So today let's talk about this concept of snapping to something called tangent, point of tangency. So basically, if I was just freehanded, I'm going to turn off my object snaps for a moment. If I was trying to connect this circle to this circle, and of course I did that freehand, you're going to see how terrible it is when we zoom in. If I wanted to connect those two things, I would have to know exactly precisely the one point on this circle and the one point on this circle where a line could be drawn so that it blended smoothly from a straight line into that curve. And that point where the line blends into the curve is called the point of tangency. So you might have heard that word tangent before if you've taken some math classes where we talk about sine, cosine, tangent, and related terms. Well, in geometry, tangency refers to this condition of a line or an arc blending in precisely and perfectly into another line or arc. So, of course, I freehanded it, um, but let's just take a look. Is this line tangent to that circle? Well, no, it's not. It doesn't even touch that circle. So, how about this line? Is this line tangent to that circle? Well, not really. I wouldn't call that a smooth blend. It kind of bangs right into the circle. Right? It hits it here on the corner. It's very abrupt, the transition between line and arc. So for a smooth transition, there is only one way to have AutoCAD do that for you. It's to ask nicely, and it's to turn on a snap called tangent. So here's the tangent object snap. I'm going to turn it on in the running object snaps. And I'm going to say, hey, I want to go from here to here. And the nice thing about this snap is you don't have to know exactly where to click. You just have to get it in the neighborhood, and then when you click, bam, AutoCAD will find the only location on that circle where a line can seamlessly blend in from arc to straight and then back to the curve of the second arc from straight with perfect smoothness. Alright, and if we zoom in, we see that the line is really touching the circle at that single point of tangency where that's possible. So I use the running object snap down here at the bottom of the screen to do that. Of course, I can also just say, I'll turn my object snaps off. I can also say, hey, give me a line, and I can say TAN, tangent, start with a tangent. Right, and when it says where do you want to go next, well, I can type my snap TAN to get to the second one. And then if I wanted to use these three circles, kind of like under the hood of your car, your drivetrain, your air conditioning pump, your water pump, your AC unit, we could do a tangent from here and then right click as you hold down the shift and say give me another tangent. Right? And we're creating these tangencies. Tangent from here to the TAN over here. And then for the last ones, I'm going to turn on my object snap and just ask nicely, hey, run me some tangents from here to here, from here. Well, you know what? Let's do this because we can also go from one side of the circle to the other, right? Because there's only one point on the circle where it can blend in smoothly if it's coming at that angle from that direction on this circle. And then the same thing this way. Bam. Okay. So this is tangency as it refers to constructing lines in geometry. And AutoCAD makes finding the tangent point and drawing tangent lines and arcs very simple. Our next object snap, if we work our way down a little bit, It says find the geometric center of each shape and then draw a half-inch radius circle at the geometric center. Well, what's the geometric center? You could define geometric center as the point that you could balance. If this was a 2D shape cut out of like a piece of cardboard, the point of balance, of equilibrium. So like right there would be the geometric center of a circle. We could say give me the center, and of course there we have it. That is the very center of the circle. Okay. Now other shapes are a little bit harder to find the geometric center. If we asked for a square, well, there's a couple of ways of finding the geometric center on a square. Right? We could do a couple of things. We could say, hey, if we go from the midpoint of that edge to the midpoint of this edge, and the midpoint of this edge and the midpoint of that edge, right? And isn't that going to be the center, the geometric center? Another way, probably a better way, is to go from corner to corner. If you drew a couple of lines from corner to corner, the intersection of those lines reveals the geometric center. Right? So there's a couple of ways of finding the geometric center on a square or a rectangle shape. When shapes start getting weird, though, it becomes a little trickier. We could still do the corner to corner trick here. On a triangle, triangles require you to do a little bit of trisecting, where you have to draw some lines that are perpendicular to the edges. I'm going to say give me perpendicular. Bam. Give me perpendicular. Bam. And then move that to the midpoint. So what I'm doing is I'm doing a lot of roughing in work here to try to find out, hey, on a triangle, where is the geometric center? And as shapes get harder and harder, like the trapezoid here, or this development shape, or this crazy thing here, finding the geometric center, or the centroid, is going to be very difficult. So to simplify that, when we have to find the geometric center of a polyline or of a closed shape, we're going to just find the object snap for it. Geometric center is an object snap. And if I say, hey, give me a circle, and I move near the edge of the shape, do you see how that lit up in the middle? Right. Circle, there it is. There's the snap for geometric center. And on my weird shape here, I'll do the same thing, and then bam, just like I constructed earlier. How about my triangle? Did I do it right? Yup. 0.5. And it is just so much easier, even on simple shapes, to use the snap. How about this trapezoid? Can you imagine trying to find out the centroid, or the point of perfect equilibrium, if this was a planar surface? This would be terrible, right? So circle, and then bam, there it is. Okay, and on our development shape here, bam, that would be the point of equilibrium, the centroid. And then on our crazy shape here, same thing. Where is there it is. Okay, so what's the deal? How does it work? You've got to have a polyline. You've got to have a completely closed shape. It's a polyline if you'd like to find the geometric center of the figure. Okay, so object snaps to tangent, object snaps to geometric center. We skipped perpendicular a little earlier when we did our last series, so let's do it now. Start here, and I want to go 90 degrees to the line that's there. Well, that's the end point, that's the midpoint, that's the end point. How do we get to 90 degrees? Well, you can say give me the PER, give me the perpendicular. And then there, it's a little symbol. It looks like a right angle sign, right? So now that line is 90 degrees to that edge. Cool. How about if we start here and try to get perpendicular to there, right? So I'll do a shift and right click this time. Give me perpendicular. Bam, there we go. And again, that would be a 90-degree angle between those two lines. Very good. So you can start out in space and try to hit something at 90 degrees. Or in this case, we're going to start down here on the line and go out into space. So I'm going to say, give me a line. And when it says, where do you want to start? Don't start here. Type in PER. And we're going to start down here. And you see what's happening as I move my cursor? How it's sliding up and down that edge. But it's staying at 90, right? So we can create perpendicularity between new geometry and existing geometry, either from away from the object to the object or from the object away from it. Our last little snap we're going to look at is snap to parallel. So start here, okay? Click, line. Now I want to snap to the parallel. I basically want a line parallel to what's there. So P-A-R, parallel. Now this one's a little weird. What you're going to do is you're going to hover over the line. And do you see the little parallel symbol? Two little lines side by side, yellow color. And when you see that and the little tag pops up that says parallel, it means it's found the line. And now as you slowly move away, here's what you're going to see when you're parallel. It'll say bam, there you go. See, it's giving you kind of like a dotted line to follow. And if you click, you know that those two lines are parallel to each other. I'll do the same thing down here. Line, start here. And I'll say shift right click. I'll say, hey, I want parallel for one shot. We'll leave it there, hover. When it says parallel, it's acquired the line. And now you can set up your second line parallel to that first line. Okay, so honestly, if you can operate object snaps with endpoint and midpoint, intersections, center, quadrant, perpendicular, tangent, geometric center, and parallel, that's fantastic. That's an awesome set of tools that you're going to be walking around with. A lot of tricks up your sleeve there in order to make your geometry accurate and neat.